Hello. Hi, Thomas.
Hello.
Hello.
All right. Nice to see you again on this call. I don't know if anyone will join other than that, so maybe if you have something, we can just start some discussion in free form.
Okay. Um, so I was talking with David this week, and we were discussing about the resource quota, like the CF organization quota, CRT, and its implementation. So I was talking with him, and it is not a something we need like right now. So I think I could like join some. I don't. As you said, there is not someone working on that already, but I could start working on it. And like my first thought was to make like a prototype, like just a functional prototype, so we could then expand that and escalate that. But as I we are not like we don't need this. So like right now, I think I could work on a more robust architecture on that. So yeah, but basically that's it. I've made some. I thought some. I thought about some possibilities to make this happen. I also researched about the resource quota of the Kubernetes native solution for that. And I, as I understand from the Corifi architecture, like the basically the way of doing this would be just to make like on the API, I would have to make an endpoint, and this and not to make an endpoint, but get the Cloud Foundry endpoint and implement it into Corifi, and that and by that, this endpoint would be used to create a resource, which would be like Cloud Foundry, it's like CF resource quota, like no CF organization quota, and then this would be reconciled into a resource quota, like a native Kubernetes resource quota.
Yeah, this is
Of course,
correct,
yeah.
I guess. This is correct. This is how everything works in Corifi. It's basically a translation layer. There's the V3 Cloud Foundry API on top, and then we translate requests to resources that we create Kubernetes. Usually these are custom resources, as you have seen, CFApps, org spaces, etc. And the quota will be yet another one. And what you're describing sounds like maybe the space quota because it can be natively implemented. Because these spaces in Corifi map exactly to a namespace on Kubernetes, but orgs actually map to a collection of namespaces. And then org quotas become a little bit more involved because you have to do some housekeeping yourself. You cannot just directly translate in a stateless way to the Kubernetes quotas. Kubernetes, I forgot the exact name of the native resource, but because this resource will work in the confines of a space, right? And if you want to put quota on org, we haven't really thought about how this might look, but you can imagine that there's some accounting that needs to be done on top. Um, Maybe it will involve propagating mm, objects as we do with permissions right now. But it needs to be explored. That's why I said in that long message that I wrote that maybe one viable way to go at it will be to first implement space quotas because that seems to be relatively easy. I mean, it's a big change. A lot of code needs to be written, a resource needs to be introduced, but it's not, there's an obvious solution. But then the problem is that once we start thinking about the org level, we might find out that our space quota design is not really good enough, and we might need to do back propagate some changes. So it could also help if we start thinking from the offset about how our quotas are going to work. But yeah, I
Okay.
mean, it will probably be useful for you because if you haven't written a lot of code for Coryphe yet, it will probably be useful if you just write some handlers that create resources. It's really a big change. That's why I also suggested that you can work on some good forest issues, some small things to get a feel for the project. So you said that quotas are not super urgent for your organizations, which could probably mean that you can work on a couple of PRs before we start doing that while we basically flesh out the design of this. So yeah, I don't know. It's up to you really. If you want to just dive in and write a prototype, that's completely fine also.
Okay. I think I will start. Then I will start working on some smaller PRs. But like about for me to better understand the Coryphe architecture, like the way I would do this, the organization, not specifically organization quota, because we would actually need space quotas, and it is easier to do. But as Coryphe is not made for us, we would I could not just make a solution that would work for us, like for VR Factory, and not for the entire project. I could make a prototype, but it should escalate. And basically, for me to implement this, I would need to define a new custom resource, a new Kubernetes custom resource, which would be space, like Cloud Foundry space quota. And from this, like, where do I go? From there, I don't really know what should I do in the code. Not because I already want to start doing it, but just for me to understand better the architecture.
Yeah, okay, so I guess once you have created a resource, you need to write controllers that reconcile it. You can actually see, you can take a look at our existing controllers. I already pointed you to the security groups, but they're not implemented yet. But you can look at what controller is simple. I'm afraid that they're not too simple, but for example, CFFs are translated into stateful set via a couple of controllers. Like, I don't know if you're very familiar with how Kubernetes development goes, but when you apply a resource, it's just written in a database, and that's it. And then the database is being watched by the controller runtime, Kubernetes controller runtime, and basically when you create a CFApp, a specific controller that declares that it's watching apps gets triggered. And the controller can do various kinds of things, like it can see if this app already has some state for it, like if it already has pods deployed. If not, it can create new pods based on the parameters that come. So basically, it's like a functional pipeline. It's you have an input, which is the resource, and then you have to output something, which is another resource, but it will be Kubernetes native. So you basically have your quota as an input, CF quota, CF space quota, and you have to basically translate it down to Kubernetes native namespace quota. And I think that's
Okay, so like,
relatively easy, right?
yeah, and like like from my manifest, because not actually manifest, like the CF client would automatically manage the request, so we would not, like, this would not be written in any manifest. It would just implement it, the resource, the space quota, directly by the CF client. And by there, like, the resource definition, the custom resource definition, is defined by AML file. How does the CF client translate that into in a YAML file. And how this, like, does it work like parameters? So it goes through the reconciler and makes like another YAML file to the Kubernetes to interpret it?
So the CF client, it will basically produce requests to the Vitry API. And that's what you can see. I don't know if you have seen the definitions of the Vitry API. I think I've pointed to them, but I'm going to paste another link in the chat as we speak. So if you go to this link, and there will be also sections about quotas, space quotas, or quotas, CFCOI is going to hit to produce requests to these endpoints. And as you have seen, we implement those endpoints in the Kurifi API module. And there we basically translate the REST request is JSON, but we translate it to Kubernetes resources. So this is the first YAML that I guess that you're talking about. There's no YAML file, but there is the Kubernetes client that creates a resource. It's the same thing that you do when you kubectl apply a YAML file. In our case, we more or less create resources programmatically on request from the Cloud Foundry API. And the other YAML that you're talking about is what the controller is going to output. Again, you don't physically produce a YAML file, but you programmatically call Kubernetes client and give it a literal. It's very similar, right? It's the same thing in Go form. And that's, I guess that's what you're talking about. Like the translation, there are two levels of translation. One level is Vetri API to Kubernetes resources, but custom Kurifi resources. So that happens in the API. When I call the post whatever quota endpoint, the Kurifi API module will create our custom resource that we're going to define, which is called CF space quota or something. And then the controller sees that an instance of this resource is created, and it creates Kubernetes native resources that are going to actually enforce the quota.
Thomas, I'm not
Okay.
sure how familiar you are with controllers. When we started our Kubernetes journey, we found that the KubeBuilder book is quite helpful. Actually, this is a resource that we occasionally come back to. So it greatly explains the concept of custom resources and controllers. So basically, that's the bit that should take place after the API creates your CF fork, CF space quota custom resource.
Okay, so basically Kurifi calls the Kubernetes API directly to make the native resources.
Yep.
Yes, yes, this is
Okay.
Kurifi API does that, and the Kurifi controllers, the other part, it doesn't simply call the Kubernetes API, it more or less lives in Kubernetes as a controller, as an extension controller, because when you define a new resource, it's just data, and if you wanted to do something useful, then you have to implement a controller, and this controller becomes sort of like a Kubernetes extension. So Kurifi is Kubernetes native in this way, because you have custom CRDs like spaces, orgs, apps, and you have controllers that know how to translate these CRDs to other things that are already supported, like stateful sets, services, etc., so that your application is running and is routable and all that. And this is the controllers part, and the API part is actually what enables people to use the CFCOI, because if you should create, because Kurifi can already be used purely from Kubernetes by applying its resources, but no one knows how to do that. People know how to CF push, and in order for us to enable them to do that, we need this API module that translates basically REST requests to resources. So then I can target the API and I can push an app, and it boils down to 10 or something requests, and these requests are, each request knows what to do, creating object on Kubernetes, and then the controllers kick in and convert those resources to useful stuff on the cluster. So it's basically, yeah, a big automation.
Okay,
yeah.
so like we could even connect a backend directly to the Kurifi API without the CF client like intermediation.
Exactly. Yeah.
Okay,
No one is really
that's
doing
actually
that.
really good to know. Okay.
No one is really doing that. I guess the CF push example is going to be actually pretty difficult because CF push does a couple of things underneath. It deploys the package, then it what does it do?
Starts a build.
The package, starts a build, creates the app. Then when the build is done,
Creates
it uses
processes.
Droplet and sets it on the app, and then it starts the app, and then etc. It's like maybe 10 actions. So if you want to do manually from Kubernetes, it's going to be a very hard thing to do. But actually, Kubernetes is an automation platform. You're unlikely to do it just by hand using kubectl. You're probably going to be writing a different application. Like the Kurifi API is just implementing the CF API, but you could be implementing other APIs or just your custom automation on top of these resources. But that's not really related, right? We're really talking about the classic use of CF CLI to Kubernetes and then controllers. I pasted this KubeBuilder book in the chat that Danny mentioned, and I would recommend, there is a very useful tutorial that walks you through step by step on how to implement a cron job in Kubernetes. So basically, there is no CF API here. You just start by defining a custom resource and then implementing a simple controller that translates your cron job to a Kubernetes job. Really similar to what you're trying to do because all controllers are similar. They have to boil one resource down to other resources. So if you go through this, I guess it will take you, I don't know how much time, a day or two or whatever, but it's really useful. And I think it will, after you do that, it will be a lot easier to think about the resource quota thinking Kurifi.
Okay.
Get to know the tools and all that. We don't use KubeBuilder directly as described in the book, but we'll get to that as well. The Go code is almost yeah, what you need to know. So that's a useful hint from Danny. I think it will really benefit you.
Okay, I'll read the references. And I will probably start working on other issues, but I will also start working on starting now to actually build the API and the controller of the resource quota.
Yeah, you can do that in parallel. I mean, there's no pressure from our side to work on any particular issue. It was just a suggestion that it might actually help you get, you know, acquainted with the project. So it's up to you really. Yeah, I guess taking those in parallel wouldn't hurt. You can start writing this control. It's going to probably take a long time, and while doing that, you can also do small stuff. Yeah, up to you. If you have some questions, you can always ask in Slack because these calls are not very. It's every 2 weeks. So yeah. If you're wondering about the design or all that, unfortunately, we haven't had a lot of time to think about anything related to quotas and the design because we have been busy preparing for the CF Day Europe, which is next week. I guess after that we might have a bit more free capacity, but I'm not sure because we also have other priorities. But yeah.
For my part, this is basically what I wanted to talk this meet. So okay, I will start working on it.
Sure. Sounds great. Sounds great. Yeah, we don't really have other topics because nobody else have joined. Something that we are planning on doing, because we are collaborating with some people in Europe, and this time slot's a little bit too late for them, and that's why usually no one joins or just 1 or 2% joins. We are planning to have this meeting a little bit earlier, and I think you said it's okay for you, right?
Yeah,
This
it's
now
even better.
even better. Okay, that's great because it's even better for them as well and even for us. I guess this slot is because we're working with US people a lot, but it's already 2 years ago, and yeah, maybe this slot is just not convenient anymore. So it's at 6:30. So Danny, what time did we plan? 2 hours earlier or something?
I don't remember.
Do you?
We
What
planned
did I?
for 3:30 set, which is
But 4:30.
2
Our time it's
hours,
2
2
hours
hours earlier.
earlier. So how is 2 hours earlier? Does it work?
For me, yes.
Yeah. Okay.
Awesome.
Great. Cool. Because we also checked with some other guys from Europe. Cool. That's really good. Then I guess I hope next time there will be also more people, so that you can also hear what they're working on. It can be like a bit more collaborative. But yeah, I guess we don't really have, the three of us are actually working daily, so we don't really need this sync to sync between us. So we really need it in order to sync with you and with other contributors. And if it's only you in this call, I guess, unless you have any other questions, then we're done.
Yeah, no, like for me, that's it.
All right. Cool. Yeah, go through these materials, ask us anything in the channel, and yeah, we can even put up ad hoc meetings like this. I mean, I guess if you have serious, it looks like we have serious time zone overlap, so we could even have meetings in person if necessary, if Slack is not enough or anything. We
Okay.
can, like, if you hit some issue, we can maybe help debug it. We have done this previously with other contributors, I guess. Yeah. And just you have to just ping us and we have to arrange something.
Okay.
Cool. If that's it, then I guess let's just get some time back and go back to work. All right. Cool. See
Okay.
you around, Thomas. You have a nice rest of your day, and yeah, see you soon.
Thank you. See you all.